How's it going, Algebra 1-2, folks? So this is a quick video over sort of the basics of what we're doing right now as far as talking about distribution and the factoring process. So as you've been going through these Khan Academy videos, you've seen a lot of sort of review about the distribution property. So looking at this first problem right here, if I have something like 5x times x plus 3, I know I can use my distributive property to multiply 5x throughout this binomial. So 5x times x becomes 5x squared. 5x plus 3 becomes 15x. So this is something we are pretty good at. We've been doing this for a while. And starting at this point, we're going to start thinking about this process backwards. Can we start from a standard form polynomial and factor it out? Can we sort of do this process backwards? So let's see if we can do that. So looking at this right here, we have two terms, and we want to kind of figure out what do these two terms have in common. So you might notice the first thing is that both of these terms have an x. So what I'm going to think about is I could envision this where we had this x on the outside and it was multiplied through. In other words, what we're looking for is a common factor. So both of these terms can be divided by x, so we can take an x outside the equation. Now let's look at the constants, or the coefficients. So I've got 20 here and 4 here. Both of those numbers divide by 4. So that's our greatest common factor altogether is 4x. So now what we've got to do is figure out what's left over if we undistribute, right? We're kind of taking this 4x out of both terms. So if we're dividing this out or undistributing it, what's left over? So 4x times what would get us back to 20x squared? Well, 4 times 5 would be 20, and x times x would get us back to x squared. Okay, so 4x times 5x gets us back to here. So now I got to figure out 4x times what would get us back to 4x. Well, we just need to multiply times 1. 4x times 1 gets us back to 4x. So we learned the distribution property can take a factored form and rewrite it in a standard form. And factoring, or undistributing, can do that process backwards, looking at standard form and backing up into factored form. So this was where we started this, but what we're going is to be able to do this on a bigger scale. So you started to look at distribution properties where we have a binomial times a binomial. Binomial just means a polynomial with two terms. So each of these chunks has two terms. So we can use our distributive property pretty much the same as what we did before, but we have to distribute both of these terms, the x and the 2. So let's distribute our x. We get x times that x times 4. We also need to distribute 2 times x and 2 times 4. We'll get to that in a second. So x times x gives us x squared. X times 4 gives us 4x. Now, if we distribute the 2, we got 2 times x and 2 times 4. A lot of times you'll hear this process called foiling. So foiling is just a cute way to remember this because we multiply the first terms, so that'd be the first two terms, so f, first terms. Then we do the outside terms, so the outside terms. Then we do the inside terms, and then we do the last terms. So F, O, I, L, first, outer, inner, last. So you'll hear me call this foiling as well as factoring. Cool, so we're not quite done here yet. This can be cleaned up a little bit. We can combine some like terms. So I got my x squared piece, but then I have a 4x and a 2x. I can stick those together. That's 6 x's all together. And then we got plus 8. All right, so what we're saying here is that x squared plus 6x plus 8 is the same function as x plus 2 times x plus 4. This one is in standard form, this one is in factored form. So what I want to do is double check to see if I got that right. So we started with x plus 2, x plus 4, and that's this function. Quadratics have this nice parabola shape. So let's see if what we came up with, x squared plus 6x plus 8, is the same curve. And it is. So this is a great tool for you to use to check yourself. Once you think you have something factored, you can throw it into Desmos to check and see if that graph is the same. So let's see if we can think about this process, because where we're going is to be able to do this part backwards. Just like we can distribute here, or thinking backwards, we can undistribute or factor here. We want to be able to do that process, but with a quadratic. So this is a little more complicated. How can we take something like this and then break it down into those two pieces? So before we try this, let's analyze where we got these numbers. So the one number I've got here, the c value, the constant on the end, is an 8. So if we look back at where we started, 8 was made by 2 times 4. 2 times 4. That's how we got to 8. Okay, so maybe it'll be a rule that whatever number we have on the end, we need to multiply the two pieces to get to that. And if we think about where do we get this number, 6, well, we added 2 and 4. So if I were looking at this and trying to solve, I'd have to figure out, well, what numbers add up to 6, and at the same time they multiply to give us 8. So let's see if we can think of a new example and solve this using that logic. So this might start to sound familiar. All year long we've been taking a look at these diamond problems. So a diamond problem is like this, where we sort of complete this little puzzle, where we want to figure out what are two numbers that multiply to give us 20. So we're multiplying to get this number 20, and then we're adding to get 12. That was supposed to be a little asterisk star multiply symbol. Anyway, so we are multiplying to get 20 and adding up to 12. So for some of us, that number, those two numbers are going to jump right out at us. We're going to understand what those two numbers are right away because we're really good at our times tables and we have these things memorized. But if the numbers don't jump out to you, we can think carefully about this and see if we can figure it out. So I always like to start with this c value. What are all the ways we can multiply to get to 20? Well, if I think about my choices, I got 1 times 20, 2 times 10, and 4 times 5. So these are the 3 different ways we can multiply to get 20. So not only do I have to multiply to get 20 though, I also have to add up to get 12. So 1 plus 20, not 12. 4 plus 5 is not 12. So these are the perfect numbers. It's going to complete our little diamond puzzle. Okay, so these numbers are what we're going to use as our factors. So 2 and 10 are going to be the constants in our two little chunks. So we got x plus 2 and x plus 10. This process is deceptively difficult. At first it looks really simple to try to figure this out, but it can be really tough to kind of figure out what's going to multiply to give me 20, then add up to 12, and it gets even more complex when we start throwing negatives in there and other things like that. So we'll see some problems get much more difficult, but to start out, this is what I want you to get, this basic understanding. And again, when I am factoring, and if I'm a little bit unsure, I can use something like Desmos to check my answer. So let's throw Desmos up here, and we'll start with the function we were given, x squared plus 12x plus 20. So that function, if you zoom out a little bit, that function looks like this. So we said that that was the same thing as x plus 10, x plus 2. And we can verify on Desmos right here that those are the same function. That's not what I'm looking for. All right, x plus 2, x plus 10 is the same function. You notice I put mine in a different order when I plugged in the Desmos, but multiplying two things together, it doesn't matter what order they're in, right? 2 times 3 is the same thing as 3 times 2, so that doesn't really matter. But we've just verified that these are the same function. This one is in standard form. That's what we call that. That's where everything's multiplied out. And then this is in factored form. So you might be asking why we need to do this. And rewriting this is very difficult to write with. Rewriting a function into factored form can tell us a lot about the graph. So we're not worried about that this week, but just to kind of give you a heads up of why we'd want to do something like this, take a look at this function and take a look at these 2 points right here, -10 and -2. Those points should look really familiar. So that's the benefit of factoring. It's going to help us find those x-intercepts to really understand something about our graph. Cool. I hope this kind of helped supplement the Khan Academy stuff. Good luck this week, and reach out if you have questions. Thanks, guys.